Good morning, everybody. Today we're going to be working with just trig functions and actually right triangle trig again. We did this at the beginning of the trimester, and we're going to go back and do the rest of 7.1 with this. Um, this assignment does not have a MyOpen Math assignment to it, so make sure you're doing the book work, and that's why there's no key online for this. Uh, you'll turn it in with just scanning it or taking a picture of your assignment, just like you did last week with the establishing identity worksheet. But there's 4 story problems. We're gonna go through them and just general ideas behind them, but pretty simple day. It says a surveyor. Let's go. A surveyor can measure the width of a river by setting up a transit at a point C on one side of the river and taking the sighting of a point A on the other side. Refer to the figure. After the turning through an angle of 90 degrees at C, the surveyor walks a distance of 200 meters to point B. Using the transit at B, the angle beta is measured and found to be 20 degrees. What is the width of the river rounded to the nearest meter? So it gives you a diagram here. Whenever you're doing these, you want to figure out what side relationships you have. Right now we have opposite and adjacent, so we want to use tangent. So tan of 20, or tan of beta, is equal to opposite over adjacent. So just plugging in all of the known information. Hard part is picking which trig function you want to use. But this one, again, we have opposite and adjacent, or we're looking for opposite and we have adjacent. So you'd either want to use this or cotangent. But from here, super simple solve. You just have to multiply by 200. So 200 tan 20 is equal to B. And then if you type that in your calculator, it's 187.94-ish, but it says to the nearest meter, so we want to round that to 188 meters. And that's all there is to it. Again, this is mostly review, so it should be quick, it's painless, just refreshing ourselves on what the trig functions were built to do. Straight trail leads from the Alpine Hotel. Elevation is 8,000 meters, and then to a scenic overlook elevation of 11,100 feet. Sorry, 8,000 feet over there. The length of the trail is 14,100 feet. What is the inclination of the trail? So we're just trying to figure out beta in this question. Our diagram already has it listed for us, but the difference between the two elevations is the change in height. So we want to use that 3,100. And then it says the trail length, which is actually the hypotenuse here, is 14,000. This is like the actual amount that you'd travel, 14,000 feet. You're not doing the horizontal distance. You're doing the actual distance you'd travel if you were to walk on this trail, which is probably the confusing part with this. So we're just trying to figure out this elevation. Surveyors may need this to figure out if you need to have any special signs saying it's too steep, or if it's paved, you may need to have wheelchair access, things like that. But we need to figure out this angle, so we have opposite over hypotenuse. So sine is the one we would like to use. Sine, this is beta. Opposite is 3,100. And we have 14,100. It's not solved yet. We need to solve for just beta, not sine of beta. To get rid of sine, you have to take the inverse. So we want to take the inverse sine of that fraction. That's the exact answer. If you were curious to figure out the decimal answer, which most of the time I prefer just the exact, it's 12.7 degrees-ish. But again, exact answer is nice. My math tends to like the exact answers. We've seen that in the past now. All right, meteorologists find that the height of a cloud using an instrument called a ceilometer a ceilometer consists of a light projector that directs a vertical light beam up to the cloud base and light detector that scans the clouds to detect the light beam. See the figure below or left. On December 1, 2001, a Midway Airport in Chicago, a ceilometer with a base of 300 feet was employed to find the height of the cloud cover. If the angle of the elevation of the light detector is 75 degrees, what is the height of the cloud cover? So again, we have a diagram. Right now we need opposite. We have adjacent to that angle, so we're going to use tangent 75 h over 300, and very similar to number one, except this time we're using tangent. Multiply by 300. Oh, 300. Tan of 75 is equal to h. And so again, that's exact. On my test, or on my pre-work, I think I typed in 30 instead of 300. So I think it should be, and I don't know the decimal after that, but because I rounded differently. But yeah, it should be about that. Yeah, that seems about right. Which leads me to a good side track, because what I had written down on my paper is this, which gives you about 111.96. This should raise some red flags. For one, I didn't use the correct number, but if I just wanted to write that down, 75 degrees is bigger than 15 degrees, so 15 degrees is producing 300. That means that h should be bigger than 300 because it's opposite to the bigger angle. This is not bigger than 300, so this is definitely wrong. We know why, but it's definitely wrong. It's always good to go back and check, does your answer make sense? This doesn't make sense. So that's why. So my pre-worked stuff had an error in it, but it was nice that I caught it. So yeah, always check your work. Make sure it's coming out the way it should. At least the ratios are plausible. Adorning the top of the board of trade building in Chicago is a statue of Ceres, the Greek goddess of wheat. From the street level, two observations are taken 400 feet from the center of the building. And the angle of elevation to the base of the statue is found to be 45 degrees. The angle of elevation to the top of the statue is 47.2. See the figure below. What is the height of the statue? So basically we're going to figure out the height of the building, and then we're going to figure out what the height of the building plus the statue is, and then take the difference to figure out the height of the statue. They use b and b prime, which looks like b to the first, but we say b prime when we say things like this. So I'm just going to use that as well. But we start off, we know adjacent, and we want opposite. So again, this is tangent. So we're going to say tan of 45 is opposite. Now 45 is b in 400. Solving for b, which would be the height of the tower without the statue, would be 400 tan 45, and I'm not gonna figure that out. I typed in everything at the very last step to get the closest to the exact answer. Repeat the process. We get tan 47.2 is equal to b prime over 400. Still opposite over adjacent. Now b prime is equal to 400 tan 47.2. And then the statue height is equal to b minus b prime, which if you type all of that in your calculator should be about 31.96. And that would be feet. Okay? So not too bad. These are the 6 problems I can count. 6 problems that you need to do for your assignment. Make sure you actually do those if you're going for the college credit. Make sure you're doing your 30 minutes of work if you're not. But check back in. Make sure you're working on it. But till next.